Hey class, well, we're about halfway through the semester, and I wanted to make this video to talk to you guys about what you should get from this class, how you can apply it to your life, and what ideas you should take away from it. So, in physics, our research is all about the scientific method. And in these labs, what we are doing is we're not just teaching you physics, but we're also teaching you how to use the scientific method. So I want to go over the scientific method with you so that you guys can be conscious of it as you are doing your labs and apply it as needed. So, there's different ways of doing this little flow chart here I have on the screen. Some people, like to define things differently, but this is the way I like to show it. So we start with an observation. We observe something, and that causes us to ask a question about it. Then we form a hypothesis as an answer to that question, and then we design an experiment to test that hypothesis. And then we collect our results. Now, either our hypothesis will be supported or it will not be supported. Either way, we report our results. Now, if the hypothesis is not supported, then we go back to earlier steps and look at is our question well defined? Should we maybe change the question we're asking? Is our hypothesis wrong? Should we be changing this hypothesis to ask or to answer more precisely or differently? And we also look at our experiment and think, does our experiment have flaws? Are there things that we can improve about this experiment? Now, for your labs, the observation, question, and hypothesis parts are all going to be predefined for you. Even the experiment is predefined. But as many of you guys go about your lab reports, right, some of you find yourselves coming to results that don't really make sense, right? So you have a very high error percentage, a high percent error or percent difference, right? Or a standard deviation or something. You have something in your data that suggests that your hypothesis uh, isn't accurate, right? Well, in these labs, we know that the hypothesis is very well tested, right? So it probably means that you made a mistake with your experiment at some point. So when your results don't support the hypothesis, I want you guys to recognize the position of that in the scientific method. And that should cause you to think, okay, well, let me look at the experiment again and see if I made some mistakes. Um, maybe I made a mistake. Maybe I recorded something incorrectly. But let's go back and check. And you go back and look at those and you correct those mistakes. Well, maybe now your results support the hypothesis. And then you put uh, that in your report, your improved results. So don't simply accept bad results. Uh, and there's a tolerance for this. There's a threshold, right? These labs aren't designed to be super time consuming, so don't spend hours on hours trying to perfect this. But it should jump out to you if you have some unexpected numbers, some bad numbers. Go back and work through this. And so, while this method is the scientific method, it is used in science by scientists. I use it in my dissertation work for trying to answer physics questions. You can apply this to real life, right? You know, say that you can apply this method to cooking, right? Say your observation is my pasta is very salty. Question: how much salt should I put in my pasta? Hypothesis: I should put this much salt for this much pasta. Or hypothesis: the salt amount of salt affects how salty the food is. Experiment. Make pasta using different amounts of salt. Results, see how it tastes, right? And so using this method, you can now cook better pasta. It's simple as that, right? Say you have your observation is that in the afternoon you start to feel brain fog. Question: what is causing my brain fog? Hypothesis: maybe your hypothesis is I'm drinking too much caffeine, or maybe I'm getting too much sugar in my breakfast, or maybe I'm not eating breakfast and that's causing me to not have the energy, right? Whatever it is, you come up with a hypothesis, you experiment. Say if my hypothesis is I drink too much caffeine in the morning, my experiment is, well, let's see how I feel when I drink different amounts of caffeine or maybe no caffeine at all. Our results is how we feel, you know? Now, hypothesis supported or not supported. If it is supported, then we know, okay, then if we want to feel better, we should drink less caffeine. Now, maybe our hypothesis is not supported. Then we can go back and say, okay, did I do this experiment wrong? Or maybe is something else causing this brain fog, right? But that, in my opinion, that's the purpose of these labs is to get you used to thinking in the scientific method, which you can then apply to your career and to your real life as well. Labs have been going good so far. I think pretty much everyone's been doing a good job. So keep it up and let me know if you have any questions or want to talk. Peace out.